So this example 19, we've got a diagram which shows a rectangular block of ice cream, and the ice cream is melting, so this block is actually getting smaller. Now the first part of the question here asks you for the total surface area A, which they're giving in centimetres squared, in terms of x, and using that to help you write down an expression dA dx. So the first thing I'm going to look at is the picture here, and I can see that the two ends of that picture in terms of their surface, those two square ends, look the same. So for our surface area, I've actually got two ends that are the same size, and you can see that those ends, two lots of x times x, and because we're doing length times width here, so x times x centimetres, plus I can also see that because it's a rectangular prism, you've got this side here, which is the same as that side, which is also the same as the side on the other side and also the side underneath. So you've actually got four sides that are the same, and those four sides would be 5x centimetres times the height, so length times width, or width times height, which would be x. So the area, surface area, would be 2x squared for this part here, plus this would be 5x squared times 4, which is 20x squared. Okay, so you can see that our surface area then would be 22, 2 plus 20, x squared, and that would be centimetres squared because all of our measurements here are actually in centimetres squared for surface area. Centimetres times centimetres. So we've got A. I'm just going to draw a box around that because that's really useful. 22x squared centimetres squared. Now the question asks us to write down an expression for dA dx, and I know all I have to do there is differentiate this expression. 2 comes out the front to make 44x, and because this is now differentiated, we have area, which is centimetres squared, per x, and x is in centimetres. So I can see here in terms of the units that I'll get a cancellation. So we now have dA dx equals 44x, and the units there would be centimetres. Okay, so that's the first part of the question done. For the second part, you can see there that it's asking, given that the ice is melting, so the total surface area is decreasing at a constant rate of 4 centimetres squared per second, calculate the rate of decrease of x when x is equal to 2. So what we need is when x equals 2, we need the rate of decrease of x, so dx, and you can see there that it's not really telling you any information about what you need to decrease with respect to, so that would be dt, so with respect to time. So that's what we're interested in, and I'll just put that there. So now that we know what we need, we actually have to have a look as well as that at what we have. Oops. So I can see here that I know a couple of things. I already know dA dx, which is useful. I can see here that I've got centimetres squared and s, and it makes sense that the centimetres squared there is a area. So this is decreasing total surface area. So we know that dA and ds, s is time. So I should really have written here that time, is going to be represented by t, which is going to be in seconds. So we have A with respect to time, and again I'll just write here so you can see. This is because you have centimetres squared per second, so a change in area with respect to a change in time, and that's 4 centimetres squared per second. Now the key thing here is the word decreasing. This surface area is not increasing but decreasing, it's going down, which means I put a negative in here to show that we're decreasing the surface area. So the change in A with respect to t is negative, it's getting smaller. So we now have dA dt, and now what we can do is we can try and put together what we need, which is dx dt. Now looking at what we have, we know dx, and we also know dt. So they're the two things that we need. What we do need is the dx to be on the top, so we're actually going to have to flip this over. So I'm just going to write underneath in light blue dx dA, so I've got my dx on the top line now, is 1 on 44x, and that's over centimetres as well. So now we've got everything we need to put together dx dt. So I'll do this in red. So we've got dx dt equals dx dA, it's got dx on the top, times dA dt, and check, yeah, the dA's would cancel and leave me with dx dt. So dx dA is 1 over 44x centimetres, and dA dt is -4 centimetres squared per second. So in terms of the units, centimetres will cancel, so we have centimetres per second, and that makes sense, centimetres for x per second for t. And then we've also got -4 over 44. So I'm just going to get rid of this part here, so we can put it over here. Oops. That much room should be okay. I'll just put a line there as well so we don't get confused with that top bit. So we've now got dx dt equals -4 over 44 x, and it's centimetres per second, and I can simplify that, divide the top and the bottom by 4, which is -1 on 11x centimetres per second. Now it's worth looking back at what you needed. You can see here you need to know, okay, the rate of decrease of x when x is equal to 2. So we know the rate of increase of or decrease of x, but we need it particularly when x is equal to 2. So when x equals 2, we have the change in x with respect to time is -1 on 22, 2 times 11 centimetres per second. And you could do that if you wanted to with decimals, but I'm just going to leave it that way. So that tells us in terms of the sides or the edges that each of these sides here on the square ends are changing in terms of their length with respect to 1 over 22 centimetres per second. And also, if you wanted to look at what's going on here, the change here, that's 5 times x, so it's 5 times as big. So this particular one would actually be decreasing at a rate of -5 over 22 centimetres per second. So these sides here decreasing at a rate of -1 over 22 centimetres per second, that's their decrease. And the decrease for that long side is a little bit bigger, -5 over 22. So the answer for this question, what is the rate of decrease of x when x is equal to 2? The rate of increase of x dx dt at x equals 2 is -1 over 22 centimetres per second. And remember that the negative sign indicates that this shows that the side length is decreasing because of that negative sign.